In this video, we would like to solve this example, the limit of x e to the x as x goes to negative infinity. Okay, so the first thing we need to do in every limit is to evaluate the function at the point. And the point here is actually negative infinity. So let me plug in negative infinity in here to see what we got. So as x goes to negative infinity, what happened to x? Let me graph the function x. This is the function y equals to x. It's a line. And as x goes to negative infinity, as you see, when x goes to negative infinity, the function goes to negative infinity as well. So we get a negative infinity in here. How about e to the x? Let me graph e to the x. So this is y equals to e to the x. And as x goes to negative infinity, okay, right here, as x goes to negative infinity, as you see, the function goes to 0. So I get a 0 times negative infinity. That's an indeterminate form. Okay, so how can we evaluate this integral? We are going to use a trick, and the trick helps us to use L'Hopital's rule to evaluate the limit. Let me recall L'Hopital's rule. Okay, what is that? L'Hopital's rule says that when we have a limit of a fraction f of x over g of x as x goes to a, and a here can be a point or any form of infinity, positive or negative infinity. And then if we get 0 over 0 or infinity over infinity, okay, plus or minus, then the limit of the fraction is actually the limit of derivative of top over derivative of the bottom. Okay, that's the L'Hopital's rule. But in here, we don't have the fraction. We just have the multiplication. Okay, so somehow if I want to use L'Hopital's rule, I need to change this into a fraction. Let me tell you the trick. So I'm gonna write x e to the x as x goes to negative infinity. And then I'm gonna rewrite this as x over 1 over e to the x as x goes to negative infinity. So what did I do actually? I just bring e to the x on the denominator, and in that case I just flip it. I wrote a fraction 1 over e to the x in here. Okay, so let me evaluate the integral right now. What do I get? So I'm gonna take the limit of the numerator x, as we did in here, is just negative infinity over, and then what happened in here? I have 1 over e to the x. So we know that the limit of e to the x as x goes to negative infinity based on here is 0. So I have a 1 over 0. And 1 over 0, any number over 0 is a form of infinity. Okay? So in that case, I get negative infinity over infinity. Perfect. So this is one of the forms of L'Hopital's rule. Now I'm gonna use L'Hopital's rule in here. I'm gonna write LH in here, just an abbreviation to remind myself that I'm using L'Hopital's rule. And then based on the L'Hopital's rule, this can be the limit of derivative of top, which is just 1 over derivative of the bottom. What is derivative of the bottom? Let me just rewrite the bottom in here as e to the negative x. Okay, so you know that if you have a fraction 1 over, let me just write it in complete form, 1 over, 1 over, okay, so let me rewrite the bottom. The bottom, I have 1 over e to the x, and I can rewrite this as e to the negative x. Okay, you know that when we have something on the denominator and we bring it up, the exponent gets negative. And in that case, e to the negative x derivative is negative e to the negative x. Okay, And if I want to write it in the form of a fraction, I get 1 over e to the x one more time. I just bring it down to make it nice. Oh, I don't want to do that. Okay. So now let me rewrite the bottom. I have what? I have on the bottom, I have e to the x, and I can rewrite this as e to the negative x. This makes it easier for me to take the derivative. So derivative is here, would be negative e to the negative x. Great. So let me put denominator in here, negative e to the negative x, as x goes to negative infinity. Very nice. Let me make this one a little to the right. Okay, so now what do I get? I get 1 over negative e to the, now I have a negative x and I'm going to evaluate it at the negative infinity. It would be negative of negative infinity. If I just want to cheat a little bit, I get 1 over negative e to the infinity. E to the infinity is basically what? What is this limit? As x goes to infinity, as you see, e to the infinity is basically infinity. So what do I have? I have 1 over negative infinity. Any number over infinity is basically 0. Very good. So instead of these parts that I just write it for myself, I can just rewrite them as 0.